Sir, good afternoon,
sir. Good afternoon. Yeah, can you hear me?
sir. Yes, sir. Sir, this is Vanav Kumar from NIT Arunachal Pradesh.
Okay.
Yeah, please.
Yes. Sir, you are my external examiner for one of my students.
Yes,
Oh.
yes, I remember.
Yes.
Okay.
Yes.
So I welcome all the participants, and first of all, I welcome Anindya sir. So I think, yeah, sir, people are joining slowly. So should we wait for a couple of minutes, for maybe 1 or 2 minutes?
Yeah, sure.
Yeah.
So Anandya sir, how are you?
Yeah, I mean, I'm fine. Can chat privately?
Yes, sir. Okay, sir.
Yes.
So more people are joining, sir. I think this will start the session. So very good afternoon to everyone present here virtually in this FDP. I welcome our speaker, Dr. Anindya Goswami from IISA Pune. Sir, I thank you for this, finding out your time from your busy schedule and to spare that time with us by sharing your knowledge amongst us. So I welcome again all the participants who are attending the FDP. So, yeah, I think, sir, you have turned on your video. Is it? Okay, fine. Yeah. So let me briefly introduce our speaker today, Dr. Anindya Goswami. So before moving to the session, Dr. Anindya Goswami received his bachelor degree in mathematics from St. Xavier College, Calcutta in 2002. Subsequently, he joined the PhD program at the Department of Mathematics in IISc Bangalore. Following the completion of MS in 2005, he received the National Award for SPM Fellowship for the best performance in the NET in mathematical science. He got a doctorate degree from the same department in 2008. In the following 3 years, he carried out postdoctoral research in the University of Twente, Netherlands, INRIA Reims, France, and Technion, Israel Institute of Technology. He joined IISA Pune as an assistant professor in 2011. He is an associate professor in the same department since 2018. He has also served as a visiting faculty at the Macquarie University, Australia, and the Justus Liebig University, Germany. His primary area of interest is mathematical finance. He has supervised PhD students. He has published various national and international papers in national and international journals. So we are very happy to have you, sir, here. And let me say that, yeah, the topic which you are going to discuss, everyone in this FDP is eagerly waiting for. So they have been, they have been gone through this option pricing. They have been gone through to data-driven approaches. But this mixture is the first time in this FDP it is going to be discussed. So with this, I hand over the session to Anindya sir, and by thanking him again, and we all hope that this session is going to be very much interesting and very much beneficial for all of us. So now the session is over to you, sir.
Thank you, Kuldeep. Thank you very much. I thank Kuldeep for inviting me for this FDP. I also know that there are, very good response from the community. Participants are there. I'm really happy to see that. I would try to explain things as much as possible. And since I would be talking for 4 hours, basically 2 hours today and 2 hours tomorrow. So I divided in the following way, that first 2 hours would be mostly option pricing in continuous time, and the second 2 hours would be about machine learning approach for finding out price of options. Thing is that before adopting a machine learning or data-driven approach for option pricing, it is also important to understand that what are the intricacies of option pricing in theoretical manner. Okay? And what I also find important is that the historical development of pricing option. Okay, that is also very important because, as you know, in the inauguration meeting, Professor Ari Krandiker mentioned that when you study financial economics, then it is not actually same as studying physics, chemistry, biology, some other natural sciences. Because in other natural sciences, you are trying to discover hidden rules of nature. Okay? And when you try to discover and you make it public, that does not affect the way nature works. Okay, so nature keeps on continuing having the same rules throughout the time. But in economics, when you discover something, the theory you make public, the public only interact in a manner that gives rise to the economical phenomena. So each and every discovery and the information added to the public also in a way changes the rule. Okay, having said that, it becomes very important to know also the history of option pricing, because here you may not need to know history of development of say, for example, discovering the law of gravity to understand exactly the law of gravity, or to solve a problem using the law of gravity. But here it is a little different. Okay, so having said that, I also would like to confirm from Kuldeep that it seems that in this workshop, the participants have seen discrete time option pricing. That means option pricing in the discrete time settings. Kuldeep, could you please confirm?
Yes, sir. Yes, sir. Actually, Professor Karandikar sir has also discussed about the discrete time pricing. But sir, we did on a very scratch. I mean, some basic terminology, and in the today's lecture, I discussed some PD approach with them. So they know a little bit of that. So if you go with the continuous time option pricing, so they will get it, I believe.
Okay, fine, good. So that is a very good news that the PD has been introduced. Okay, I will talk about the PD also. And what about no arbitrage principle, etc.? I mean, are those also?
Yeah, sir. Professor Karandikar, sir, actually discussed a lot about no arbitrage principle.
Okay.
So he discussed this.
Okay, so the no arbitrage principle is basically the fundamental, basis of finding fair price of option. Okay. However, when you try to inculcate that notion of no arbitrage principle in continuous time settings, then it becomes more theoretically involved. And I just wanted to avoid that thing because that requires a very good fluency in measure theory and probability theory, which I do not expect for heterogeneous audience. So, however, as Kuldeep has mentioned that the PD has been introduced, so I would consider the knowledge of PD, that Black-Scholes PD, and however, without compromising on rigor, so I would derive the Black-Scholes PD. Deriving Black-Scholes PD means that giving justification why should the solution of the PD is the correct price of option towards the end of my talk. Okay, so this is actually done in many different ways. Of course, the way Black-Scholes have done is different than what you find in textbooks, in the modern textbooks, for example, in the book of Karandikar and Kalyanpur. And also the way I would derive is also a different, another approach. Okay. So anyway, so without talking much about my approach, so let me start. But yeah, so I should start from very scratch, very beginning. I would talk about what do we mean by stocks and derivatives? How many different derivatives are there? And then what is the whole total scenario of financial market? What is the place of derivative in the whole context of financial market? So these are the things I would talk, I would clarify, keeping in mind that many of the participants for the first time are possibly hearing about financial derivatives. And then, so this part might be a little repetition, but that is, I think, would be enjoyable also. And then towards the end, I would mathematically derive the Black-Scholes PD. And then, of course, I would not present the solution of the Black-Scholes PD because that I understand Kuldeep has already done. And yeah, so yeah, maybe I would talk about the complementary part of Black-Scholes, what has not been covered.
Yeah, sir. We have discussed a little bit about the solution of Black-Scholes PD and its numerical formulation also. Okay. Numerical solution also. Yes, sir.
Okay. So I would rather talk about the derivation of the PD. But the derivation really, depends on many different approaches. So I would adopt an approach which is, which would require the least amount of preparation. Okay, so let me start from here. So when we talk about price of an object, okay, of any product, we just expect a single real number, a single number. However, when you talk about one particular asset, whatever that may be, that could be a piece of gold, that price changes over time. So it depends on time. It's very important. This is actually starting point of the discussion of in math finance, that you have to accept that price depends on time. So whenever you would think about price of any, in the financial market context, you always need to think that it is not a single value, but it depends on time. So that means it is a function of time. That's the first thing. And then the question comes, what type of function? So what type of function is the thing which is, you are going to ask for and you are going to look for, and then you would expect that you would be given a function of time. Now, there are many different assets. First, let us talk about risk-free asset. This is an artificial type of asset. Okay, you can think that there is nothing which is risk-free, but ideally, in an ideal situation, you can think that there is an asset which is risk-free. So in the real life scenario, the fixed deposit appears very close to a risk-free asset. So I give an example. Imagine that. So what do you mean by fixed deposit as an asset? That we call anything as a product if we pay money and acquire that. For fixed deposit, you pay, for example, 1,000 rupees to your bank account for fixed deposit, you get a certificate. In present days, certificates are digital, but in earlier, it was actually a paper certificate, which basically, used to say that a promise, which contained a promise, which says that after maybe 1 year, you are going to get 1,100 rupees if you, bring this paper back. Okay, so that means you purchase that certificate with 1,000 rupees. That means that certificate is the product. Okay, so now if you look at that type of thing, then it has a price. Huh? So you can think, okay, now it has a price which does not depend on time, okay, because it has a particular price. But imagine that after 2 months, you would like to have some money, but you do not want to take the certificate because bank, for example, your bank does not allow to close that prematurely. So you imagine the bank has the flexibility of transferring the certificate. So you transfer the certificate to your neighbor and you get some money. And how much money are you going to get? Is it exactly 1,000 rupees or little less or little more? The answer is little more. Why? Because imagine that today you deposited, and then instead of 365 days later, you go to your neighbor after 360 days, then you are going to get some money which is of course little less than 1,100 rupees, because you have to wait 5 days, to get 1,100 rupees from bank, but you need early, you get less, but of course you would get little more than 1,000 rupees. Okay, so that intuitive understanding really says that the piece of paper what you have that you call the certificate of fixed deposit has an intrinsic value which is changing over time. Okay, so how does that price change over time? Okay, so if you look at various different ways, the fixed deposit works. Okay, like annual compounding, quarterly compounding, monthly compounding, or continuous compounding. Okay, so like green line, so it is saying that if bank gives yearly compounding, and then you have put maybe your FD for 10 years, then the price of that thing, that paper is changing, according to the green line. Okay, on the other hand, if the bank gives continuous compounding with the same interest rate, okay, here all the curves correspond to 20% interest rate. That I think you can understand the 20% interest becomes 20. So then continuous compounding gives the highest way of appreciation. Okay, so this is the simplest financial asset what all of us know, a fixed deposit certificate, and for that, taking that example, okay, I could explain how price or the value of that asset changes over time. Okay. Now we come to more interesting things, because risk-free asset is something which we all know, and and there is hardly any challenge, okay, unless your banks are shutting down. So this is another kind of certificate which we call stock. Okay, historically, these type of certificates were issued. So here this is one historical certificate
Sir, Anindya sir, just sorry to pause you. Uh, Someone is saying in the comment that it is little voice is little low. So will it be possible to make it little louder?
Yeah, let me try. Yeah.
Thank you, sir. Thank you so much.
Yeah, let me try. Okay.
Yeah, now it is even perfectly fine.
Okay.
Very loud. Yeah.
Okay, good. Thank you for notifying me.
Thank you, sir.
Okay,
Thank you.
so yeah, so this is an example of a certificate. So this certificate, was issued in 1967 by the New York Central Railroad Company. So the organizations, they want some money for their capital, okay, so for building infrastructures, etc. So they uh, uh, give away some certificates saying that when you pay me 100 rupees, you also, so this is like $100, okay, so like it says something in the calligraphic, fonts, very hard to read, but this basically says that it does not promise any return, any particular value. It just says that you have paid this, thing, and then you have purchased 100 units of $1 cost of things, you have invested that, and also, over time. So it basically share of the company, okay, some certain share. It does not speak anything very specific, how much money, etc. It's some share, and then you would you own that type of share. So what does it mean? That if that organizations make some profit, would give some bonus and dividends, and you would be able to get it. However, if the organizations, do not perform well, then, you are not going to get much. Okay. However, in general, these organizations do well, then only, people purchase their shares. So that is the whole foundation, okay, of purchasing shares. And then, after some time, after a few months, you want your money back. So what you do, you just find out another buyer, and then you sell the certificate to that person. Then that person would start receiving the dividends, etc. And you will be paid the money what is the proper value of this share. And this is very much driven by market mechanism, like demand and supply, etc., and many other things. Okay, with and demand also depends on the performance of the organization's news, etc., with various different factors. So this fluctuates a lot. This price fluctuates a lot. So if you imagine you are at time 0, and then you are looking at past 10 days back, 20 days back, you can see the price of that share was fluctuating. Okay, so this one can get from nowadays in online terminals. Okay, one can check if you have purchased share, 1 unit share from, say, IBM, and then you can check in the internet. It's in the open domain, everybody can check, and you can see the past price of that particular asset over time. Okay, so this much part, you have all seen, you have all understood by now, last few days, you have seen the stock price moves. But now, if you want to compare this with the thing what I have shown here actually your time was like 0 here, and you're thinking about your future, the future progression. Now one can ask the same question, that what would the future price? The future price is uncertain. No one knows how it happened. It could be any of these curves or maybe some more, here and there. Okay? So that is basically, manifestation of the uncertainty. Okay? So this has no, I mean, it is just random simulation. Okay, I have done, but I want to convey the amount of uncertainty involved for future time distribution. Okay. Okay, so that is the whole part. I mean, the whole reason of talking about stock market and and investing in the stock market. Okay, because that is risky. Okay, however, all that is risky, but still, growth rate often appears to be better than the bank's interest rate. So people try to invest. In many countries, the bank's interest rate is much smaller than our country. Okay, where inflation is really controlled. I mean, almost. So there, one does not get any appreciation for keeping money in bank. So for investment, they need to invest in stocks. Okay, for appreciation of money. So now, before coming into the mathematical formulation of various different features, we must first feel what is happening here. So the uncertainty is something what we have all understood, but how to quantify that uncertainty. Okay. So this is the notion. See, for example, you look at the history of physics discoveries of gravity, etc. You would see that what was stopping Galileo to discover gravity or law of gravity was something, that notion of mass. Correct? I mean, otherwise he discovered everything almost. So here, like the notion of uncertainty, how to quantify that thing. So the financial market has inherent uncertainty. Okay? So uncertainty is like oscillations. You can imagine that way. So if oscillation increases, say a term volatility factor is more. So I mean, how much increase and what is the quantification of decrease? Okay, that is matter of formulation. But we understand from this figure where we can see extreme kind of differences. See here oscillation is less, here oscillation is more. We can say that, okay, here volatility is less, here volatility is more. Okay. However, how to quantify volatility? Okay. So before quantifying, we must understand that what does it physically mean? It physically means kind of nature of oscillations. Okay, so this is high volatility, this is low volatility. If we try to draw a volatility line, then possibly here also high, here low, here high. So it would be like this red curve. So low here, high here, high. Okay. Okay, but how to do that? I mean, how to get the values, precise values? That is the question. So in general, you just look, you can just only see the price of asset, okay, and the volatility, what we are now figuring out, okay, or trying to formulate is a hidden number. I mean, it is not appearing anywhere, but you have to measure, you have to infer that thing. So whenever volatility you hear, you have to have that notion in your mind. I mean, when we mathematicians present some mathematical, formulations, models, we just write down sigma is a volatility. It appears very concrete to us. Okay. However, if you are really practitioners and if you are really, as Professor Kandikar was telling in the inauguration, that I mean, for the sake of writing papers, one can write lots of papers and one can do lots of mathematical research. But if you really want to do it in a meaningful way, you have to connect to the reality. And if you connect to the reality, there is no volatility there. I mean, you just have stock price. Okay. So yeah, I mean, I really enjoyed actually the comments what he made in inauguration. So I mean, and that was really influencing me for creating this slide. Okay, so here, so this is the volatility kind of notion, and one has to quantify it. There are of course some statistical methods to quantify it. Okay, one can come up with some statistical methods, and people may differ, in their opinions, etc. But it is, well accepted when people say what is volatility. There are only 2-3 different notions. What do they mean? And then, so to avoid confusion, people actually gave names to those, like historical volatility, implied volatility. These have been, formulated, decades before. So this has been formulated, but yeah, so based on this understanding, volatility is hidden, so one has to estimate that. Okay. Although you formulate, doesn't mean that you can actually, find it accurately. You can, of course, define. You can give a definition. Okay, so now, why do we talk about derivatives and options? Okay. So this is the context, okay? So to understand the need, one must actually understand the situation of volatility. Volatility is the main reason why you need derivatives, okay? So derivative products are purchased to mitigate investment risk. Since there are fluctuations, so there are some investment risk. So derivatives are some products which are there in the market just to mitigate the investment risk. So that is the main thing. Okay. Of course, when something is in the market, one can use or misuse that in many different ways, but this is the main motivation. Okay. So here, imagine just two-party things, okay, holder and writer. Writer is the person who actually creates the derivative, and holder is the person who holds the derivative, okay, that contract. And since a writer created for some reason, what is the reason? Is it that earning some money out of it? So, for example, for bank, fixed deposit was a certificate written by bank, and you paid some money to the bank. Okay. Similarly, here also, writer wrote one certificate. Okay. What is that certificate? What is written there? That I would come later. Okay. But something, and that contract has been given to holder, and holder pays a price. By doing so, the writer actually takes some risk, because the holder transfers some risk to the writer of the option contract. So how does it happen? So this thing I would explain with some specific examples. Okay. So buyer pays price for transferring the risk. Only a right model of volatility can give the right price of derivative. Because if you do not have right model of risk, you cannot figure out how much is the risk, and you cannot also find out what is the fair price of that risk. Okay, so this premium, of course, depends on the risk or volatility. So yeah, it was not easy to talk about some mathematical concept without using any mathematical notions, but notations. But anyway, I think I could convey the intuitive idea to you. Now we come to very precise example. So imagine that there are two parties. So the girl is a seller, the boy is the holder of that option. She is the writer of the option. Okay, and in this example, the present date, you can think that this is, on October 1. October 1, the stock price is $9.5. Okay? And the boy wants to purchase one contract from her, which would say that on December 1, the boy would be able to buy the same stock from the girl with a different price, fixed price, $10. Okay. So what is happening? Why not the boy is going to the market to buy the stock and then just hold it? I think is that possibly the boy is anticipating the stock price. He doesn't need to today, on October 1. He possibly needs on December 1, and he thinks that the stock price may be cheaper than $9.5. So he doesn't need to pay $9.5 now. he would be able to, I mean, he can pay later. I mean, smaller to get it from market. However, since he needs it deliberately on December 1, he, is ready to pay a little more if he cannot get cheaper. So if the stock price, contrary to his belief or expectation, goes really high, that he considers as a risk, then he is truncating his risk by setting a fixed price $10 and saying that I would buy the same stock from you only with $10 on December 1. Do you agree? If you agree, what should be your condition? Okay, of course, now the girl would charge some money for transferring some contract. The contract would bound her legally obligated to sell the stock at that price $10. She would not take that obligation unless she is properly rewarded. So she would, demand some money, some premium for that contract, some value of that contract. So that, for example, here you can think $1. It could be $2, it could be half a dollar, it could be something which is possibly really vague at present. So that is the question. So how to find out this premium value? Okay, so this is the question for finding the price of a call option. Okay, this is a very concrete example where call option. Why this is called call option? Because this boy is going to buy. Okay, I mean, one can of course imagine a different type of option where the boy is going to sell. So then that is called put option. Okay, so I guess you have already seen the definition of option earlier, but okay, so this diagrammatic explanation might clarify a few doubts if you had. So this is precise definition of call option, that at a prescribed time in future, a person B, okay, the holder of the option, has right. Okay, the B is the boy, has the right to buy the stock. Okay, so here for the first time I'm denoting the value stock. So stock S stands for stock, capital T stands for the price of that stock at time capital T. The capital T is in future. So as I told, the price of asset always depends on T, the time, and then the dependence should be reflected. So here the reflection, doing it by putting subscript. And G stands for the girl. Okay, so now there could be many different questions. Why should she agree? Huh? Why should such contract exist? One can actually argue that if you see that the contract value 0 makes this boy in the most benefit, puts the boy in a very advantageous position, and on the other hand, the value of this contract, I mean, too high, for example, exactly $9.5, say, puts her in very advantageous position, then there could be a value in between, and where both of them can agree upon. And if that is happening, then of course such product would be viable. So there are many questions, not only about existence of such contract or viability. One can ask that what would be the way, how could she actually mitigate her own risk? Okay, is it a foolish step? No, there could be some systematic algorithmic way to actually cover her own risk, etc. So there are many questions. So actually, if you think that you don't understand it completely, thing is that is natural, because the whole topic of option pricing theory is to understand these things completely. Okay. However, instead of understanding the solution of the problem, we are here focusing on understanding the problem itself. So the problem itself should be clear by now. If it is not clear, you can ask me, because we have enough time. We should be able to. Okay, so now we come to the precise question that two central issues that what should be the premium value. The premium value is something.
Sir, sorry to interrupt. Sorry to interrupt. There is a question in the chat box that is there a relationship between volatility and volume?
Okay. Yeah, of course. I mean, if you know what is volume, that means you know a little bit about stock market. Yeah, so volume is basically amount of trading happening on that particular stock, and empirically it has been as observed that if there is a direct relationship between volume and volatility. However, volume is something quantifiable. You can actually observe volume because these are the numbers. Volatility is something you need to estimate, and then it depends how you estimate. So if you estimate like using historical volatility, which is basically annualized standard deviation, then annualized standard deviation of the return, then you would see some kind of direct relationship. So it has been observed and has been reported in many research articles. Any other question, Kuldeep? Because I don't see the comments.
No, sir, that's fine.
Okay.
I think we can proceed.
Good. Yeah. So two central issues. Okay. So how to find out the price? Now to find the worth of some commodity, over time it is changing. I mean, try to solve the problem when it is easiest. It is easiest when that product is in the extreme situation, that means at time capital T itself. So that means the boy has not gone to her on October 1, but December 1 itself. And then, of course, that if he wants such contract which says that, I want this at $10. Okay. And on 1st December, the stock price is $9.5. It is ridiculous. The boy would not go. I mean, boy would actually purchase the stock from the market. So if you denote this $10 by K and this value as S subscript capital T, because this is stock price at capital T, then the difference, S minus K is negative. So when this difference is negative, the value of the contract is 0. So that contract is no more viable. Okay. However, if it is, strike price he did not propose as, $10, but $9, in that case, I mean, the girl would agree to give him that stock at $9, although the stock price is $9.5, only if she somehow manages the additional $0.50 in some way. And only way that she can get compensated the $0.50 if she charges that as the price of the contract, because she hardly can do anything. I mean, she hardly can, manage this $0.50 in any other ways, because there is no time that she can actually generate any money by investment, because it is the same day. So then we know that the value of the contract would be exactly the difference. So if it is S and this KK is say $9, so 9.5 minus 9 is $0.50. So we understand that in the extreme situation, when the time gap or time to maturity is 0, okay, so then the worth of the asset is ST minus K. Plus means stands for the positive part. So the maximum of ST minus K and 0. Okay, so this much is clear. Okay, now what we need to now find out worth of an asset. Listen very carefully. We now need to find out worth of an asset whose price is this thing in future. So now the problem of finding price became finding out net present value of some random payoff. Okay, so present value of this payoff. Okay, so this is the kind of amount the girl would receive at the time of capital T, where capital if she sells that object at capital time T, but at time small t or at time 0, what should be the fair price of an of a product whose payoff at capital time T is 0. Okay, so like net present value, the notion of net present value, if you have seen in banking, literature, or in your investment, many times you have come across possibly NAV, net asset value, or net present value. Yeah, so net present value. So that should be the price. Okay. It sounds quite easy now, but yeah, there are many uncertainties. Okay, so there is another problem. Okay, so how much the holder should pay to the writer at time 0 for an asset worth ST minus T plus at time capital T, because one cannot quote a price which is a random variable. I mean, if I'm going to a shop, I am willing to get a product, I cannot pay a random amount of money. I have to give it very precise. Any money, I have to give a particular value. So a deterministic value, okay, for one object which has some random payoff at time t. Why random? I'm saying because it is unknown. No? In future, I don't know what is this value. And then second question is that by taking this premium, what the girl would do? How should the writer initially generate an amount, this thing in future? The problem of hedging the option. Okay, so now we can have some mathematical intuitions. We know that how to plot S minus K. So if the horizontal axis is S axis and vertical axis is the cost of the option, and at capital time T, I have a graph which depends on S. At times 0 or some earlier time also we can expect some graph which depends on S, but we don't know those graphs. Of course, we know graph, at the time of maturity. So the blue graph, the dependence of option price on S minus K plus, what we have actually argued. And we know that if we have 3 months in our hand before the maturity, its price should actually follow closely like this. We can intuitively understand that, because if present stock price is here, in 3 months time stock price may move to the right, and then that means there is a chance of appreciation, and then it would be useful or worth, it would gain some value. So then at time 3 months earlier, if stock price is here, the option price would not be just 0 like blue line, it would be little positive number. Okay, if you have more time, possibly the worth would increase. So these are the kind of intuitive understanding that type of curve one can expect. The problem becomes that how to find out the formula of these curves. So that was the question what that initial time the Black-Scholes etc. addressed this question, how to find out a formula for these curves. Okay, intuitively one understood. I mean, people understood. I mean that they should follow this kind of behavior, but exact values were not. Now, a precise value of the price function depends on a precise model of stock dynamics. As I told them, that volatility, that risk, because if stock price does not move at all, if there is no fluctuation, then of course, I mean, it would not move anywhere, so the price would be 0. Huh? But if it moves, then only there is a chance of appreciation. So one needs to understand the dynamics of the underlying asset, find out price of the derivative. We are not here trying to find out price of stock, correct? Price of stocks are assumed to be known. We are trying to find out price of the contract, that price of that option, okay, which is written by that girl and acquired by the boy. Okay, so these prices are as like deterministic functions. So here, when we draw this, picture here, these are all deterministic line, maybe unknown, but deterministic. Okay. Fine. So now, let us talk about some other derivatives also. Yeah. So like put option, as I told, I have hinted that is the holder, in put option, the holder of the option gains a right to sell the stock, okay, for a prescribed price to the writer of the option. So at maturity, the stock price would be some estimate, a subscript capital T, and this would be K. So imagine that K is higher, okay, and then it is beneficial for the holder of the option. So the holder of the option would sell with higher price in that case. In an American option, the owner can require the sale take place at any time up to the maturity date. So this is also very important way to extend the notion of option, because earlier what I talked about, that the boy can only return to the girl for exercising the right at the maturity time. But yeah, so that type of options are called European options, and other type of options where the holder of the option has more flexibility, those options are called American options, and these are called exercise style. So barrier options are similar to ordinary options. This is another type of options, except that they become activated or extinguished only if the underlying reaches a determined level. Okay. So yeah, so this is also very useful. These options are also traded in the market because these options transfer not the total risk but partial risk. Since buyer takes, keeps some risk to himself, so he pays a little less to her, to the writer of the option. Okay? So these barrier options actually makes it more flexible. That okay. So there are some other type of options like Asian option, look back options, composite options. So I'll talk a little more about barrier options. Okay. So that you can understand this part more. Okay. So how it is becoming a little cheaper. So here, this is exotic category barrier option. There are two types, in option and out option. In is like getting activated, okay, and out is like getting extinguished. And up or down, that means touching the barrier from above or from below. So from in also you can have up down. For out also you have up down categories. So there are, then you can see 4 categories. For each of these categories, one can have call or put options. So like 8 different categories. Okay. So like so far you can talk about European call or put options, and in barrier with up, down, etc. And then of course you can have infinite many categories by setting the barriers. Okay. Yeah. So what is your barrier depends on that also. So you have now not only one type of options in the market, but you have plenty of things. I mean, no one actually wants to go to a restaurant which has only one item in the menu card. Okay? So like that, if you are a trader, you need lots of different things so that you can purchase here and there, and also the flexibility what barrier option gives, because it retains certain risk to the buyer of the option and it transfers the partial things. So that means it becomes cheaper. The option becomes cheaper. Okay, so. And for each and every barrier option also, like these two options, not only barrier option, for any other options, one has various different styles. Here I just talked about European style and American style, but there are in between many different styles also. Okay? like here for the Canary, Bermudan, etc., where that exercise is possible maybe in a particular interval Bermudan option, okay, before the maturity. Not as flexible as American option, not as strict as European option, but in between. Okay, so you can now have a general idea that it is like a jungle. You have a full, big list of menu card of many different type of derivatives. Why do we call derivatives? Because its price is derived from the property of underlying price. Okay, so that's why it is called derivative also. Okay, so now we try to understand a little more about barrier options. Okay, so like here up out call option, here when we talk about up out call, that means it is like call option, but the call option becomes invalid if the stock price goes up, touches the barrier, then is so it becomes invalid then. So that's why it's out, and up because it is going from lower to higher. And then at the maturity, what should be the price of stock, price of that option? It is a little uncertain because it depends in between whether stock touched or not. For example, here it is up out option kind of things. If stock price really touches and again at time t, even if it is smaller than the barrier, still option becomes invalid, or that means that options becomes worthless, value is 0. So then what we understand that the option value is not only function of the stock. It is also stock at the last time. It is also function of the history. However, one can draw the maximum value what one can get. So if if this point is below here, okay, lower than B, okay, so maximum value of the stock would be S minus K. It could be 0 also in these occasions. So like S minus K like this here. But if this point is not here but above B, then surely that means that it has crossed somewhere sometimes before. So the value of the option is nil, it is valueless. So then from B onward the so these are terminal value, maximum terminal value, okay, the maximum value at the time of maturity above. Similarly, down out put option looks like straight going down, but it's down out. So here B is the barrier, down out. So here you get this thing. Now imagine that at maturity, if the value is not going like indefinitely high as call option, European call option do appear, but it is like bounded above, then of course its present price would also be smaller than the European call option. So these pictures also highlights the reason that why barrier options lucrative and they are also attractive investors. Okay, so I just drew two different things here just to give the idea. One can try to draw many other curves for up out put, down out call, up in call, down in call, and up down out, down input and up input, many different things. Okay, you may take this as an exercise. You can just try to imagine, and when you try to do that, you get much better clarity. And okay, so I go to the next. Okay, so here I'm going to give you overview of, where the derivatives are standing. Okay, so here is the derivative market. Okay, so many different types are here. So equity, so this horizontal rows, like these are derivatives on equity, derivatives on interest rate, derivatives on credit, derivatives on foreign exchange, derivatives on commodities. And for each of these, there are many different types of derivatives. Like this is ET stands for exchange traded, exchange traded futures, exchange traded options. OTC stands for over-the-counter swap, over-the-counter forward, over-the-counter options. And then for each of these types, for each of these assets, one has many different types of derivatives. So it is really a jungle, okay? And for everywhere, for everything, you can also imagine that many different types of options. So like, for equity and exchange traded options, single share option. So we are only talking about this. This red color, what is written out of this whole, bunch of jungle. So this only we are talking about. For single share option also, there are call option, put options, barrier options, and all sorts of barrier options. And other than that, also there are some other options like Asian options, lookback options, composite options. It really has lots of variety. Okay. Okay. So yeah. So I think in this 1 hour, I wanted to give you a very overview of derivatives, okay, traded in the market and the challenges of pricing the derivatives and various different types of derivatives. Just check if you have any question. I just pause for a couple of minutes. I'd wait and check if of you have any question. You can put in. Write down your question in the comment. You can unmute also possibly. Yeah.
Hello. Hello, sir.
Yes.
Yeah.
Rohit Trivedi here. Yeah, sir. Actually, my question is related to volatility.
Yes.
As sir mentioned, volatility is something related to volume. So, in Black-Scholes equations, volatility is present. So, is there any possibility that we will add volume term in Black-Scholes in somewhere?
See, I mean, what are these? These are actually some name, correct? Some terms. What is volatility? Volatility in a Black-Scholes is just a symbol, sigma, correct? It does not say how to find out that value. It says that it is just some positive number, and that appears as a coefficient of the diffusion term, the Brownian motion term. Okay, and however, when you look at the Black-Scholes formula, and you see that if you take return, the simple return dst by st, and then it turns out to be Gaussian, normally distributed the return, and if you take the standard deviation, one doesn't know how to do that in reality. Why? Because dst by st, I mean you just see only one realization of the randomness in the time series, okay? And to find a standard deviation or expectation, that is moment, you need special arrangements. Like you need to sample many different things from the same population. However, there are some standard assumptions that you believe that first, the past 10 observation or 20 observations, there the market did not change. It is the same thing, the same population. So under that stationarity assumption, then those values, the time average, you can consider as replacement for the space average, and using that you can estimate and come up with some value for volatility. Okay, so I mean, sometimes, some terms and some symbols and some formula really, confuses that what do they stand for. Now here, what we find out, there's a formula for volatility, from historical volatility, just take standard deviation. There are lots of assumptions going on, okay? There are lots of considerations going on. Now that is a measure of volatility. Now one can of course argue that instead of that thing, what if I consider volume instead of that number? I just, I don't understand that way. I just take the consider the volume, and from volume, whatever value I get, I just put there. The problem is that whatever number would appear in the Black-Scholes model, the Black-Scholes model dictates a meaning of that. The meaning is that annualized standard deviation of the simple return is the volatility. It dictates it, okay? And if you would like to, put something else there, then you would come up with a different model. It is not a Black-Scholes model anymore, because Black-Scholes model, that model is a theoretical model, is an assumption, but that assumption dictates that unknown value sigma, if you want to estimate that, a consistent estimator, if you want to find using using assumption of stationarity, the past data, etc., of the simple data, then it must be nothing other than the annualized standard deviation. So you have no other way to put volume there. However, one can imagine a model of stock price which is volume driven. Okay, so then it's not a Black-Scholes framework; it is a different framework. One can, of course, try to figure out or something, because there are some, research. Lots of people work on predicting stock price, etc. Predicting means, no prediction is possible unless you model, right? So that model could be based on volumes, etc. And it could be very complicated, much complicated than what Black-Scholes question is for the stock price.
Sir, there is one more comment. There is one more question in the chat box that in the market, 3 subcategories are trading: in the money, out of money, and near the money. What is the range of near the money options?
Okay, very good question. Okay. So now what I talked about here is call option mainly, with that example. With that example, when I talked about call option, there it was just, very, what should I say, very, toy example and very hypothetical way where the $10, $9.5, etc. But in reality, it's not like that, correct? I mean, if you look at Nifty 50, its prices like 10,000 something, 11,000, 12,000 something. So now, now imagine, now let us consider Nifty 50 itself. So its price today, assume that it is, I did not check, so I don't know, but assume it is like 12,555. Okay. However, when options are traded or options are created by writer of the option, they generally fix strike price. I mean, not arbitrarily, but as multiple of hundreds. Okay, so there could be some options like 12,000 with strike price 12,500 or 12,600. However, the actual stock price is 12,555. So then 12,600 or 12,500, these options, having this type of strike prices could be called near the money. Okay, at the money, you can say, I mean precisely at the money, but near the money. Okay. However, if you take some other things like the strike price which is too large, okay, then it is in the money. Okay, so, sorry, so then it is out of the money, and if strike price is too small, then it's in the money. Yeah, so figure out near.
Yeah, so sir, your screen is not visible. So if you want to say something from screen, is it? Yeah, now it is visible.
Okay, yeah. So that much only. I just wanted to say near the money. Yeah. Any other question?
No, sir, I don't think they have commented
Okay.
anything. Anyone from the participant, you want to ask anything to sir?
Okay. So now I then go to the next slide, next part of this. So here, talk about some popular continuous time theoretical models of market. Okay. So you have seen some of these, Black-Scholes you have seen. Maybe Heston model you have not seen. Okay, but I would just talk about this. Okay. So a little bit of history that the first mathematical model of market appears in the PhD thesis in this theory de la speculation. So this was in 1900. Okay, it was done by Louis Bachelier. The model failed to capture the positivity of stock price because he was modeling the asset price, stock price by random walk kind of thing, the Brownian motion basically, and then which can go positive or negative both. With positive probability it can go negative. So then that was the effort by Louis Becquerel. But this is believed to be the first effort of modeling stock price and finding price of option. So Brownian motion was independently formulated, by Albert Einstein in 1905, very famous paper by Einstein. So his formulation was, not exactly in the same way as Louis Becquerel did, but it was the same object. So what is Brownian motion? So, this history basically suggests us to, understand the definition of Brownian motion. So this is the definition of Brownian motion. It should satisfy these three properties. So a real valued stochastic process, W, is called standard Brownian motion if at time 0 it is 0. And process as a function of t is continuous almost surely. What does it mean? Because it is random thing. For a particular realization, you get a whole path, time-dependent thing, and that thing is continuous. Okay. Third thing is that the increment Wt minus Ws in the time duration t minus s, that is normally distributed with mean zero and variance t minus s. And this increment is independent of the past. So if S is a present, T is a future, and then the past is 0 to S, this time interval. So the future increment is Gaussian distributed with mean 0 and variance T minus S, but that random variable is independent of all past observations. Okay, so this is the definition of Brownian motion. And mathematicians, like Weiner, etc., they studied it extensively and to reveal more mathematical properties, give mathematical foundation, how to define it, how to show its existence, and what are the various different properties. In some textbooks, the second property is dropped, and then one gets some one has to do a little more work to define Brownian motion. Okay, so but I prefer this way. Geometric Brownian motion is is a process which looks like this, that e to the power of alpha t plus beta times wt. It is a very simple formula, but it is very useful for finance. Why? Because Wt as a Brownian motion could be negative or positive, because this is the Brownian motion is like normal random variable. Normal random variable can be negative, positive, both, correct? However, e to the power of negative number could also, must also be positive number, okay? But because it is on the power of e. So this xt, if you define xt this way, it is assured to be positive all the time. So that actually makes geometric Brownian motion so popular among in math finance context. Okay, this is yeah, a big history. I mean, by Fisher, Black, and then Myron Scholes and Robert Mertens' success in deriving theoretical option Black-Scholes model. Okay, which was actually proposed in 1965 by Samuelson, etc. And then 1973 is the time when they have actually came. Okay, so next is little details about the Black-Scholes model. I mean, a very brief one slide details that you have two different assets according to the Black-Scholes model. One is to call the money market. Okay, so risk-free interest rate is R in the money market account, and the worth of the investment at time t is BT, and time 0 it is 1. Okay, so if you put t is equal to 0, it is 1, so B0 is 1. This is very clear from here. And then yeah, so this is exactly the same thing. You can write it as an ordinary differential equation in this manner. Okay. Now stock, okay, stock price, which is random, and as one participant asked a little more details about volatility. So here is my scope to actually show that thing, that this parameter sigma is called volatility parameter, and then the stock price is written this way based on this parameter value. Okay, this is just a parameter. Okay, mu is also another parameter, growth parameter. So dst is equal to mu st dt plus sigma st dwt. For the first time you are looking at, if you are looking at an SD for the first time, I must also explain what does it mean. I mean, S is the unknown, and that appears on both sides of the equality. If unknown appears on both sides of the equality, so that means it is not a formula of S, but it is an interesting equation one has to solve to find out S. So it is an equation. And this equation involves some differentials, so it is a differential equation. And it also involves some random noise, Brownian motion, so it is stochastic differential equation. It is as simple as that. It is a stochastic differential equation. And you can understand that the integration signs are missing here. Okay, so it is an integral equation. Okay, so if you integrate left hand side, you get st minus s0. If you integrate right hand side, you would get something. Okay, and then both sides involve unknown st, but you have to find out what is that st. Okay, there are ways, as you can solve ordinary differential equation by integrating appropriately. Here also you can, but then you have to have proper notion of integration. And the fundamental theorem of calculus actually helps you to find out the the antiderivative. So here for stochastic counterpart, there is Ito's formula, which replaces the fundamental theorem of calculus. So that should be applied to integrate properly and to find the solution. And then that solution, here for this case, st is equal to s0 times e to the power of mu minus half sigma square times t plus sigma wt. Okay, so as I told that time dependence, most of the time in this slide I write down in the subscript. Okay, these are all function of time. These are also function of another something, because this is random thing. Okay, maybe a function of sample points. So this is the way to denote. So now the mu value appears to be like rate. Why? Because if you compare these two things, here dbt st, here rbt dt, here mu st dt plus something. So now this thing, if you take expectation here, you would get 0. Why? Because Brownian motion, normal. I mean, the increment of Brownian motion is normal distributed mean 0. It's like increment. Okay, so this is 0. So on an average, if you take on an average, so here what mu plays role, R plays same role for bank. So if R is the interest rate for bank account, then mu should be the interest rate average, rate for the stock. So then that is the understanding of mu. And thing is that the traders become interested in a stock if mu appears to be larger than R. Otherwise, why should one invest in stock? I mean, one would invest if it has higher rates in some sense on an average. Okay? Although there are some, it does not ensure that the investor would actually gain something more than the bank because there is a random thing. However, on an average, there is a chance. So that means if investor invests 1,000 times, maybe out of 1,000, more than 500 times, investor would make some better money. Okay, so that is a very broad understanding of stochastic differential equation for stock according to the Black-Scholes model. Now we go to the subsequent developments. Because this is only the beginning of the story, there should be many other type of effort. As one of you participants was saying, like how to improve, like instead of sigma, can we have something different? To have some different models. So of course, people thought about different models. So here this is 1993, another very successful model. I mean, due to Stephen L. Heston. Heston modeled volatility not by a constant, but by another stochastic process given by a stochastic differential equation. So it is a two-factor model, right? I mean, stock price itself is a stochastic process. Stock price involves a parameter sigma. That sigma, due to Heston, is also a solution of a different stochastic process. Okay, another stochastic differential. So he obtained. By believing this model, he obtained also price of option as solution of a generalization of BSMPD, solving some extra parameter. And also obtained a closed form expression of European option. And the model gives an incomplete market for this. Okay, incomplete market means that using self-financing strategy, the trader would not be able to replicate all contingent claims in future. So the price of the contract, the option, is a little more involved. Okay, because there is no single price where both can agree upon. Yeah, so it is a likely range. Instead of single price, it is just a range. Very simple term, it is just that fair price is not a single price, but in a range. I mean, what appears in just village markets. Okay, instead of if you go to supermarket, you purchase any vegetable, you pay exact price. Okay, but you go to any village, or local subsidy market, you can purchase things in some price in a little up and down and in a range. There is a negotiation. Okay, so like that. Okay, and calibration of such stochastic model is also challenging. However, this is a significant improvement in Black-Scholes, and this is the stochastic differential equation for the model proposed by Heston. We call this as Heston model. So earlier we had one SD, one single stochastic differential equation. Here we have two stochastic differential equations, right? Because here instead of sigma, we have square root of Vt. So Vt can be thought as square of sigma square kind of thing. So sigma square, like volatility square of the volatility, satisfies another equation. Why is it an equation? Because Vt unknown appears on both sides. And it involves integration, so calculus, and also it involves another randomness, another Brownian motion W prime. But W and W prime could be correlated something or could be independent. So dWt dW prime t is like rho dt. This is another parameter. So let us count quickly how many parameters do appear here. 1, mu, is kappa, 2, is theta, 3, is 4, and 5. So 5 parameters are here. In the Black-Scholes, you get only 2 parameters. Here you have 5 parameters. So more details require more parameters. Okay, I mean, we are not surprised. But what is the intuition of VT? The intuition of VT is that if VT is drawn here, we can see that if VT is very large, much larger than theta, then this amount becomes negative. It is larger than theta, then negative. So dVT, the small change of VT becomes negative if this sigma is sufficiently small, etc. And then what does it mean? That volatility, the VT process would start coming down, on an average. On the other hand, if VT is too small, like theta is positive number, but VT is very close to 0, then this becomes positive. So positive, then VT is going to go up. Of course, that is just very intuitive and gross way of talking, but one can make it formalized. There are lots of research. People have studied it extensively, and the people who studied it extensively, after their name, this equation also has a name called CIR process, Cox Ingersoll Ross process. Okay, this is also called popularly mean reversion process. Okay, and this kappa stands for speed of mean reversion. Theta is long run mean. Sigma is called here not volatility, but volatility of volatility. Okay, volatility of volatility. Okay, so here, if you try to, if you investigate this equation intuitively longer, you will be able to realize why kappa is called speed, okay, and why theta is called mean reversion. I mean, that much part I think actually I have explained why theta is like middle. Okay, so here we need some conditions for this to make sense, because when we write the square root of VT, I mean, it should not be an imaginary number. So VT to remain positive, I mean, this sigma should be sufficiently small, because the fluctuation Brown distribution, which positive or negative, if sigma is not sufficiently small, one can push it below. I mean, Brown motion can push it below. So sigma should be sufficiently small. It should satisfy the Taylor condition that sigma square is less than 2 kappa theta. Of course, it depends on kappa theta, because kappa theta is the thing which is trying to push up. So if kappa is large, then sigma could be, need not be so small. If kappa is small, that means up push is not that much, then sigma should be sufficiently small. So these are the intuitive understanding of such conditions. And if you also want to study some more standard properties, what one can expect of the solution of this, the square integrability, one needs another inequality imposed on sigma. Basically, both the things are saying that sigma should be small. I mean, but here you need the dependence on rho also. Okay, so these are the that is the description of Heston's model. Now we have seen 2 different theoretical models, okay, and we can actually from here extrapolate that there could be many different researchers who keep on improving such models. And yes, that is true. Every year, possibly hundreds of papers being written on extending the existing models, okay, to incorporate more and more realistic features, okay. And then using those models of stock price, finding out the theoretical price of option. And there are many different options, okay. So you understand that there are lots of investigation going on, and that's why it is a very active field. I mean, the option pricing, literature or research in option pricing is also a very small part of broad area of mathematical finance, but itself you understand option pricing has lots of reach and lots of scope. Okay. So now, theoretical option pricing is one avenue that leads to study of SD, PD, etc. And also when you have PD, solving that numerically, and then when you have SD, calibrating those parameters using statistical tools. So you understand that it involves statisticians, probabilists, differential people working in PD, people working in numerics, and also like econometricians who work in modeling the asset prices. I mean, it brings experts from many different branches. Okay? So that is theoretical thing. Okay. However, uh, this field always remains open-ended. Why open-ended? Because there is a saying in statistics that no models are correct, or rather, it is actually a more stronger statement. It says that all models are wrong, but some are useful. Okay? So all models are wrong, some are useful. So in that settings, one can investigate lots of theoretical models and all. On the other hand, one can have data-driven approach, where one does not have any assumption of theoretical, asset price dynamics. So that is the thing what I'm going to talk tomorrow. But before I end, I still have half an hour, and I can explain derivation of Black-Scholes PD. Okay. So here I just summarize. The fair price of an option contract depends on the current anticipation of the future dynamics of the underlying asset. The success or failure of theoretical option pricing and hedging is closely tied to the success in capturing the dynamics of the underlying assets price movements. It's very hard. I mean, nobody knows for sure what is the best thing to do. While simplified assumptions of some theoretical models do not match the reality, a complicated model, of course, that matches the reality, but it is hard to calibrate. Okay, so these are the reasons that, these are the actually shortcomings of all theoretical models, but that does not mean that one should not study theoretical models. It is very important. Okay? People are doing. Okay, I also work on that, but I also work on the data-driven approach. Because I find that one single approach has its own scope and limitations. Yeah, so one can try many different things. Okay. Since this is a hard problem, adoption of data-driven approaches in pricing option contracts is gaining attention with the advent of superior computational power and advancements in statistical learning techniques. The data-driven approach is promising, but has its own limitations and challenges also. So it is not that one can actually replace theoretical option pricing by data-driven approach completely, because it also has its own limits. Okay. Yeah, so tomorrow's talk would be based on this last thing, what are the limitations and how to overcome some of the limitations. Okay, so here, data looks like this. As I was answering to some question that about where the money, etc. So imagine that underlying value is 6,300 rupees, okay, and strike price is 6,800 rupees. That is strike price. So here strike price is much larger than the underlying price, right? So here, stock price is much smaller. So that means it is out of the money. Okay. So here, yeah, so here you see the lots of quoted strike prices. Okay. So, data appears like this way, and you can see high price, open price, high price, low price, close price, daily data. Okay, so now I come to a discussion about derivation of BSM-PD using one approach which requires minimal amount of preparation. Yeah, but before that, I would accept some questions if one has depending on what I just conveyed.
Sir, there is a comment that range of this near the option is still not clear. So the question on the range of near the money was not clear. Just the terminology was discussed by sir. So if possible, can we have a discussion on this?
Okay, so here, for example, I can see 6,800 as strike price, and we see that these are all 50-50. Yeah, so like strike prices are multiple of 50s. Okay, so now imagine that underlying strike price on that day. This is one single day. I mean, all these are same values. Why? Because at the same day you have various different options. And now imagine, which is not listed here, there is one particular option where strike price is 600, 300. So that would be, of course, near the ATM or near the money. If there is another option, okay, European call option, okay, having 600, 300, so 6,350 rupees. This is between 300 and 350. That also can be called as near the money. Now that values very much depends on the asset. Here I'm talking about Nifty 50. Okay. Yeah, so maybe it's not, it's maybe Nifty. So here, if one has different asset, then possibly it is not in the range of 50, it is in the range of 100, or maybe it is in the range of multiple of not 50s but hundreds, but multiple tens. So how can you talk about what should be your near the money? So what one does is that one defines moneyness. What is moneyness? Moneyness is the ratio that's stock price by strike price. Okay, if stock price by strike price is 1, exactly 1, that means both are equal, so that is the ATM. But in the real life scenario, it will never be. So if it is never be, so then you can just check what is the range of what is the interval you should take around 1. So here that interval, if you take say 4% up and 4% down, okay, 4% up, 4% down, and if you translate that into a very particular asset like Nifty 50 here, then possibly you would get some. So let me just check what is the meaning of 4%. Let me use calculator. So calculator, I type 1.04 times 6,300. So that becomes 6,552. Okay. So if I talk about 4% up and down, then upper would be 6,550. Okay, 550. So that means 250 above. Okay, here. And if we on the other hand multiply, yeah, so 4% less, that means 96%. Okay, so we do that. 6,300 times 0.96, then lower would be 6,048. Okay, so 6,050 you can think. So below 6,050, above 6,550, and 6,300 is the mean. So 250 up and 250 down kind of thing. Okay. So that is kind of you can take that is like for Nifty 50. But for another asset also, this 4% rules work, because if you always talk about that, okay, look at only next above and next below, then it would be much smaller than maybe 1%. Okay, so yeah, little less than 1%, because if 4% gives me 250, 50 would be obtained by 1/5 of 4%. Okay, So imagine like, if you have 1% up and down of Nifty 50, okay, so 1.01 and 0.99 multiple of the underlying asset, you'd get something which is near the money. So it remains vague because what you really want, if you really want one single option as near the money, then maybe 1% is the best thing for you. But there is a problem. Problem is that sometimes some options are not actually traded. If it is not traded, you don't know its value. You don't know its fair price reliably. So then for that particular day, you would miss out from the data of the near the money. Okay. So what people do, they take little larger interval. Okay. You saw 1% up and down, maybe 4% up and down. That's why I was talking 4%. So to get more data, and then you have near the option, that means you would have multiple such of type of contracts, so that at least one of them, you can hope for that would have been traded, and you can see fair price. The problem does not become so dire if you are actually working with an underlying which has higher liquidity. I mean, like, which has lots of open interest. So many people are trading. But if you are working on some asset which are less traded, whose options are less traded, there, if you're near the option, near the ATM is very short, then you'd miss out lots of data. So it is better that you take a range, larger range to get data, and then of course after you getting, if in the data, you can screen out some redundant thing. Okay, so that is the suggestion that if you are working with the data for near the option, you take maybe 4% down and 4% up. That is my recommendation. Yeah. Any other question?
Yeah, that's a very good explanation, sir. Yeah, so there is written, what is real option? Manisha ma'am, I think I mean I have not understood the question, sir. Someone asked that what is real option, so I don't know.
Yeah, I mean,
What's the
yeah, I request the participant to unmute and can ask the question.
yeah. If she wants to some clarification, please unmute yourself and you can ask directly.
Yeah, hello, sir. Sir,
Yes.
actually, I came across, about the, I mean, I heard saw the term real option, and, but not very clear. I couldn't understand properly. That's what I thought of
No,
asking.
okay. No, I did not
Is
come
it
across this
related
term.
with some other type of options, or like,
Maybe I don't know, because I did not come across this term. Yeah, because
Oh,
it is, as I was mentioning, that there are many different options. So
okay.
yeah, there could be some commodities, some particular derivatives, which is termed as real option, but I don't know.
Oh,
Yeah.
okay. Thank you.
Hello.
Any other question? Yeah, please.
Good evening, sir. Yes, sir.
Yes.
Sir, I just wanted to ask, like, at NSC, multiple options are being traded, and for every option, like, there is a particular volatility, that is implied volatility is mentioned. So as the prices of the option changes, that volatility also changes. So if we want to, like, assess the price of an option, so how can we decide that volatility, or means which is dependent on other volatility is dependent on the price, or the price is dependent on that volatility?
Very good question.
Because
Yeah,
both of them are changing as the price changes.
very good. So this is really a good question. I mean, here, if you look at Black-Scholes, as I mentioned, that sigma is unknown. And given this sigma, you find out the option price. That means you first assume a sigma value, then you find an option price. I mean, find means you derive using the Black-Scholes theory. But the thing is that in the real market, okay, when you look at the data, so here in the data you see that nowhere any volatility is written here, but you of course have stock price, okay, and strike price. You have also expiry date, so time to maturity you can get from here, and also you know that closing price, okay. Closing price you can think as the price of the option, okay, at that day or on that day, okay. So thing is that one can now annualize this time difference, so figure out what is the time difference. One can take this as a strike price K, stock price, and use the Black-Scholes formula to find out option price for a particular sigma. So what sigma value? One can just keep the sigma value, so it will be a function of sigma. So now that function of sigma, okay, so here, yeah, so function of sigma is the price of option, and that appeared to be 1 rupee. Now you equate that function to 1 and solve that equation in sigma. Solve the equation for sigma. You would get a sigma value. The value what you are going to get can be called as implied volatility. That means the volatility implied by this option. But of course, one can say that, hey, I mean, I'm not interested about this option. I'm interested about this option. Okay, I would actually write down the Black-Scholes formula, which is function of sigma, and for this, not this strike price, but this strike price, okay, and this query, and I would equate, and I would solve that equation, and I'd find out some sigma. Of course, I mean, your solution sigma and the other person who used that solution sigma, they may or may not match. Okay, so actually there is also empirical study that what happens. It has been observed that at the ATM or near the money, I mean, when the strike price is the closest to the stock price, then the sigma value what you obtain in this manner is the lowest. And if you go to the, I mean, to out of the money or in the money, okay, the strike price is larger or smaller than the stock price, then it tends to be larger. So that is the way actually implied volatility behaves. But the question what the participant has asked is that over time also it changes. Yes, over time it changes. So because not only 1st January 2014, if you take the data of another time with 2nd January, you would also can solve this type of things. You would get different values. So as I told that the volatility is a gross term. Okay, I mean, like, fluctuation of risk is a gross term which you can understand intuitively, and we understand that the fluctuation very much influences the price. If the fluctuation is modeled as a constant in front of a Brownian motion, then that constant is called a volatility number, and that actually has a formula. One can actually estimate that using standard deviation. But imagine that someone came up with a model of stock price where there is no Brownian motion in the model at all. So it's a Brownian motion, you have fractional Brownian motion. And then the sigma, what appears in front of this, need not be the standard deviation or the simple return. Understand? So that type of things, that fluctuation and risk is some notion. For Black-Scholes, they have articulated that fluctuation, the risk, in terms of a single number parameter using Brownian motion. So that's why the volatility comes, and that is just a theoretical model. And when you come to the real options, you just see the option price, and then you can ask, if Black-Scholes formula has been used, then what value of sigma should be used to find out this price? That would give you some sigma value. And every time you would solve the problem, you are going to get different sigma values. But don't worry, those sigma values are close to each other, are not very far. In general, in Indian market, this, if you play with these things, I would see the sigma values like 30% at most, and maybe 7-8% at the least, and in between they vary. Okay. And they have little, I mean, some particular pattern, not very precise, but some particular pattern that particularly smile, like the in OTM and ITM they increase, and ATM they are the small. So there are some patterns, they stay in a range, and they are not exact and they are never constants. So yeah, so now the question is that what depends on what? Thing is that if you talk about reality, you have a particular option. This is a real product you have purchased, you paid in money, and the money you paid depends on market dynamics, demand, supply, and the trader's perception about the risk, and that need not be dictated by anybody's any theoretical models, need not be dictated by Black-Scholes or any other models. It could be some value, okay, some price. So price comes here, and from price you can ask that, okay, if I try to fit Black-Scholes model, what should the parameter value? So in that sense, sigma can be obtained from price. When you are talking, when you are starting discussion from the real market data. But when you start discussing from the mathematical modeling, from the mathematical world, then of course sigma starts first and you come to the option price later. Okay, so that is my answer. Yeah. So
Hello.
yeah.
Hello, sir.
Yes.
My
Yes.
question is that volatility or implied volatility calculated on the basis of closing price of a Nifty or fluctuation, because in some day Nifty will go 100 point ups, then 100 point down and close only 2-3 point up. So day volatility is very high, but closing price is only 2-3 point fluctuated. So volatility is calculated on closing price of the Nifty or day fluctuation, means low and high.
Very good question. Yes. So this is also a very important question for econometrics. Thing is that what is the granularity you should look at? So daily granularity always means you have to choose a single price at a stipulated way. Okay, so that stipulated way closing is the best way to do that. If you look at daily price and if you want to find out volatility from the daily data, you take from the closing. Okay, and whatever it does, it gives some number. Okay, now if you want intraday fluctuation, that means you are no more interested in daily data. You are working with a finer granularity, like hourly data. If you're talking about hourly data, then you take hourly data and for that you find out volatility, and it turns out that you would get different numbers there also. Okay, so yeah, so you'd get different numbers, but then always for in econometrics, when you do time series analysis and you find out the volatility or whatever, you need to mention what is the granularity you are talking about. So daily data, of course, closing price, but for intraday data, you take hourly data or something, and then you take all these things. And then high, low, close, they appear in between. What is the use of those? I mean, it has, of course, some use, okay, but not for finding volatility. Because if for volatility, if you keep on counting these things, you would get erroneous values. It would not be standard deviation. Okay.
Okay, that means in Black-Scholes we use volatility on the basis of closing price of a Nifty, maybe.
Closing price, yes. So if you are taking daily data, if you are interested in daily data, daily, then the closing of the daily. If you are working about hourly, the closing of the hourly. So you take the closing. Okay.
Okay.
Whatever your granularity is, that you take the closing of that.
Okay. Thank you, sir.
Okay.
So any more questions from the audience? Any question? Anyone?
Sir, one more thing, sir, for back working of that implied volatility, what should we take as risk-free interest rate for taking that Black-Scholes model?
Yeah, very good question. If you have, observed online calculator of implied volatility, etc., you need to put some interest rate there also. So the repo rates, are for possibly, some, banks, declared rate. Okay, one can think of that. But repo rates are, mostly not driven by market, but managed by governments. So other things are like yields rates, okay, so which are also reported quarterly. Yeah. So these are the rates, what one can get from many different online platforms. So these are the rates, okay. So the interest rates, are really small amount, really small. I mean, although your bank is giving some rate, but ideal banks rates are much smaller. So here now, you want to consider nowadays kind of things, that 5% you can consider. I mean, if you are just trying to implement something and you want to find out something, you can take 5% interest rate in your market.
Hello,
Yeah.
sir. One more question. The option price of dividend paying stocks will affected by dividend or anything?
Yes, yes, of course. So after Black-Scholes has published their paper, Merton has also written many, and then he introduced dividends in the settings, and then option price depends on dividends. If you have dividend, it appears there.
Sir, actually, my basic question is related to it will increase or decrease maybe. Option price will increase or decrease if I pay 100 rupees stock, 10 rupees dividend. Then what is the effect on option price of 100 rupees?
Ah, okay. That I would not be able to tell. Okay, so I mean, if you just search, it is very easily obtained. So you can see, Black-Scholes formula for option price for zero dividend. Similarly, you can search for Black-Scholes option price depending on dividend. You would get some little more complicated formula where dividends denoted by some delta, some parameters, and that appears with appears in the formula, and that formula would be self-explanatory. If you consider that formula, you'd be able to understand that how it really depends. Okay.
I would like to add, sir, it also depends on what kind of option you are talking on. If you are only particular about Black-Scholes
correct.
model, then
No, I think he's talking about
you can
call
directly
option.
check from the, yes, sir.
European call option.
Sir,
In that case,
my question is about call option.
yeah. In call
Basically,
option, you
call
can.
option price will be increasing or decreasing because I exercise 100 rupees strike price options and stock price is also 100 rupees. But company decided to give 10 rupees dividend to that stock. So what is the value of call option of 100 rupees stock? It will increase or decrease maybe.
Yeah, so I don't remember that. You can actually look at that, formula.
Yeah,
You will
yeah.
be able
Sir,
to
I would
get
like
some
to add,
formula.
Rohit, sir, what you can do, you can simply find out the formula, Black-Scholes formula in case of dividend paying stock.
Yeah.
Actually, R is replaced by R minus dividend. That's it. Everywhere. Just like in PD and formula also. So from there you can get it very easily. Maybe we can discuss this.
So
Okay.
so
So then
R minus B. So maybe call price, option price will decrease.
Yeah, for
In
call
that
option
case.
price, what happens that it depends on R. So directly, if R increases, the price increases. So if delta dividend is there, then it would
Decrease, yeah.
Okay, because R minus that's why it will decrease.
Yeah. Yeah.
Okay.
Okay, I think, sir,
Yeah, no other
Now,
question, and we are also done with 2 hours.
yeah, sir, it's a long session. So
Yeah,
I thank you again, sir, for such a
yeah,
wonderful. I mean, I tried to explain some of these things, the stochastic volatility models, but you explained it in a very nice way, and even I learned a lot. So thank you again, sir. Thank you all the participants for being with us, and I believe that you enjoyed this session. You learned a lot from this session. Sir will be with us again tomorrow morning from 9:15 to 11:15. Uh, and as you know that sir will be discussing on the data driven approach, the need and what is we are getting from those data driven approach in finance, in option pricing particularly. So those things will be discussed by sir tomorrow morning session, and then from 11:30 to 1:30 we'll be having Dr. Mani Mehra from IIT Delhi. He'll be talking about the machine learning approach in fractional differential equations. So we have many more, I mean, interesting sessions tomorrow. So thank you, everyone. I hope all will join tomorrow at 9:15. So thank you again, sir. We are winding up this session here. Thank you once again.